Good morning. It's Wednesday, April 1st. Probably under different circumstances, it'd be nice to, start off with a little April Fool's joke like there's no such thing as a coronavirus. That's more wishful thinking than a cruel joke. But given the circumstances, we are still in our quarantine states and our remote learning. Not to waste too much of your time here, I'm going to get right to the lesson at hand. I'm planning to give you guys a test Wednesday, but I will have that test available on Tuesday. I'm going to hold one last review session with any questions that I might have gotten either Friday or Monday and answer those questions on Tuesday. So if you have questions on any of the things that we've been doing or things you would like additionally reviewed or me to comment on, please post, comment, email. You can message me directly on Edmodo. Any of those things will work. And I'll make that Tuesday's morning review, and I'll have an exam released for you sometime, on Tuesday. You can take it either Tuesday afternoon, Tuesday night, or anytime on Wednesday. And that'll be our kinetics and equilibrium exam. I'll do it on Castle Learning again. Remember, those exams are timed, so make sure you have a good internet connection before you take it. I know a couple of you struggled with the first one, but you got it figured out. As you know, I did post all the grades on PowerSchool. The one that you're going to take next week, though, I think I'm going to hold off till next quarter. Besides putting in some comments, I think your second quarter grade is going to be current as to what it is right now. They want us to post comments. I probably won't post comments from many of you because you've been all somewhat active. Although I will say this, and it's a little bit disappointing, I get to see the number of likes on my posts, and the posts actually include your name. However, when I go to my YouTube studio, I get to see the number of views, and I'm disappointed to say that the number of views is significantly less than the number of likes, which means there's some of you going to the page, liking it, and not going on and viewing the video, or at least not viewing the video in its entirety. I don't know if you view it for a little bit and not most of its entirety, whether it doesn't count as a view. So at this point in time, I can't determine the names of the people that are viewing. If I can figure that out, I'm going to. This it's going to be a little bit for me to try and see if I can do that because it's definitely disappointing. And then you know what? It's going to show in the test grades. So you're going to have to take the test. Your name and calculated grade comes to me. You got to be doing your work, and it's clearly evident that some people are going to the post, liking it, and not viewing the video in its entirety. I need you to do that because it's the only way that you're going to learn. You still have a fourth quarter grade and most likely of Regents to take. So for those of you that aren't doing what you're supposed to be doing, probably what I'm saying right now is a waste of time because the people that are liking and not viewing aren't hearing this. If you are hearing this, tell your friends because I'm going to figure it out eventually. All right. Anyhow, here we go. I wanted to review the 23 short response questions. I have my board. I also might just hold a paper up with drawings to some of the answers for you. Remember, post questions or comments on this. And I will always answer anything that you need to have answered. Okay, here we go. Starting with question number 1. We have a reaction diagram. I'm going to circle the word energy. The word energy is on the right, indicating that the reaction is exothermic. So I'm going to draw the exothermic diagram. The exothermic diagram is going to start higher and end lower. So I have the higher, lower lines drawn on there. And now I'm going to put the hill in. I'm going to put a little point up at the top, which is higher than my reactants. to indicate the highest point of the curve with the activation energy. And I'm just going to put it together with a smooth curve as best I can. And that's all there is to it. It's as easy as that. Okay? Exothermic, reactants high, products low. You need a point above the reactants for the activation energy hill. And there you have it. That's all it is. Number 2, explain in terms of collision theory. So it says collision theory. Your answer must use collision. Right? Why an increase in temperature increases the rate of reaction. There are 2 answers that you can have here. First off, important to include in both answers. At higher temperatures, particles move faster. At higher temperatures, particles move faster. So what's going to happen? They're going to collide more often. More collisions, more reaction. Or you can also include both. It's only required one response. Or you can say, well, they're moving faster. More of them are going to hit harder. If they hit harder, more of them have the activation energy to allow the reaction to occur. Okay. Number 3, state evidence that indicates photosynthesis is endothermic. I feel that I've read this recently in another problem, but light energy, which is a form of energy, is on the left. When energy is on the left, it's endothermic. 4, compare the entropy, that's randomness, that was yesterday's lesson. Compare the entropy of CO2 molecules. Compare the entropy of CO2 molecules in dry ice with the entropy of CO2 molecules in the inflated balloon. In the balloon, they're a gas. Gases have higher entropy, right? In the dry ice, they're solids, low entropy. You need to have either one of those statements. Five. Describe how a catalyst, zymase, speeds up the reaction. No matter what the reaction is, whether it's an organic catalyst, an enzyme like zymase, or a piece of metal like nickel or platinum or vanadium oxide compound, anything that catalyzes the reaction will speed it up in the same way. Okay? It speeds up the reaction by lowering the activation energy. You could say that, lowering the activation energy. That's an answer to the question. An additional answer to the question would have been changing the reaction pathway or changing the reaction mechanism. The mechanism or pathway is the way the reaction happens. These reactions don't happen just boom. They happen in a series of steps, especially with something like C6H12O6. That's a large complex molecule. It doesn't become alcohol and carbon dioxide. There are intermediate pieces, intermediate stages. So it just changes the way the stage happens or the stages happen. So your 2 possible answers could be lowering the activation energy. That's the simpler one. The more complicated one, change the mechanism, change the reaction pathway. Those are the same thing. A mechanism is the pathway. That's the shape of the hill and what the hill looks like. Next one. We have the hypochlorite reaction. ClO negative is hypochlorite. You can look it up on table E. It's ClO negative. You didn't need to know that. And this is Le Chatelier's principle question. It says, state the effect on the concentration of ClO, okay, when there is a decrease in the concentration of OH negative. So I'm just going to show you the reaction here again. And I'm going to start drawing on it, okay? We're doing, can we see that one? We're doing this one here, and I'm pointing to that one, okay? And now it says, I'm going to decrease the OH negative. Remember, increase in concentration, move away. Decrease in concentration, you're moving to. So I'm taking the OH negative out, so I have to replace it. So my reaction is going to go to the left. So I have an arrow drawn over it, drawn to the OH negative side. That means if the arrow is going that way, everything where the arrow is a more. The other side is a less. Right? You see what I wrote there? That means the, what did they ask about? The ClO negative, the hypochlorite, that's going to be decreasing. because it wants to replace the OH negative, which I removed. Okay. Number 7, explain why the container must be closed. Well, the Cl2 is a gas. It will leave. Number 8, compare the rate of the forward reaction to the reverse reaction for this system. It says in the question, the system is at equilibrium. That word equilibrium, it's right there above my arrow, okay? You see the word equilibrium? Right? So it's at equilibrium. That means the rates are equal. Concentrations are constant, rates are equal. We disrupt the equilibrium by removing the OH or adding something else. We can disrupt it and then cause the forward and reverse reactants to change rate until a new equilibrium is reached. But at that point in time, when it's at equilibrium, all those rates are equal. Number 9, explain in terms of activation energy why it's faster. Now this one, it's specific. There's only one answer because it says explain in terms of activation energy. The other question that asked about a catalyst, it says describe how the catalyst speeds up the reaction. That's wide open. You can talk about the change in the activation energy or the change in the pathway. This one says explain in terms of activation energy. You must say activation energy, and that activation energy is lower. So the activation energy is lower. Okay. I wonder if you can just say changes the activation energy. And then someone would have to infer that you meant lower. I wouldn't do that. I would say lowers the activation energy. Why do that? All right. Number 10, it says compare the entropy of, underline the word solid, okay, and then underline dissolved in water, okay? So that's your two conditions, the solid, KNO3, and the KNO3 dissolved in water. The KNO3 dissolved in water, that's a mixture, right? It's in the liquid state. Liquids and mixtures are higher in entropy than pure solids. So the entropy of the solution is higher, the entropy of the solid is lower. Either or would answer the question. Number 11, exothermic, okay, circling the heat energy, the 196 kilojoules, it's on the right. Since it's on the right, it's exothermic. That's the evidence. The heat energy is on the right. That's the evidence. 12, state in terms of the concentration of SO3, circle the SO3 in your question, right? What occurs when more O2 is added? Okay, so I'm asking about O2. Let me underline that, okay? More O2, and then we want to know about the concentration of SO3. Remember, increase in concentration, move away. O2 is on the left, so I'm going to go to the right. My right's going to be more. My left is going to be less. Okay, just like that, you answer the question. So the SO3 is on the right, that's the more side. It will increase, right? State why the entropy, right? So the answer to number 12 is increase. Number 13, state why the entropy of the reactant is less than the entropy of the products. The reactant, solid only. Product, there are gases present. There's KCl, which is still a solid, but you also get oxygen. Oxygen is a gas. That's the largest amount of entropy, the state of matter, okay? Biggest entropy change. All right, number 14, I apologize. There probably should have been a grid that printed out. When I printed these out this morning to go over them with you, I noticed the grid wasn't there. So I sketched a little grid, okay? That grid is good enough for you to be able to solve the problem. You need times. Time is your x-axis, 0 to 20, and then your concentration is your y-axis, 10 and 0.02, okay? And now we're going to graph them. I put some points up, all right? So this is it next to the data. See if I can simultaneously point to them. Your first data point is going to be 4.5. Where's my pen? 4.5, which is about, I did 0, 10, and 20, and 0, 0.01, and 0.02. So at about 4.5, which is here, it's at 20. Okay? Am I seeing this right? I can't look at it backwards. But, I mean, you can see it. I'm looking at it upside down and on the screen until it's processed. Everything comes out backwards. You're seeing it right. I'm looking at it on the screen backwards. But graph it. At when the concentration is 0.02, the time is 4.5. 0.015 is between 0.01 and 0.02. So that's at 7. The 0.01 is 12. And the 0.005, which is midway between 0 and 0.01, okay, that's at 20. So you get points when it's graphed out that look like that. And then you draw the line, and you should get a curve that looks something like that. Okay. So that's number 14. And then 15, which is based on the same thing. Other than concentration, because this tests concentration, other than concentration, find something else that would affect rate. Catalyst or temperature. You said pressure. There are no gases here in this reaction. It's just concentration. So these are in solution, so it's not going to matter. 16, describe the relationship between concentration and time. Less concentration is more time. The rate is slower at lower concentrations, right? So the lower the concentration, the longer the time. So higher the concentration, the less time, which means a faster rate. 17, on the potential energy diagram, you draw an arrow for the forward activation energy. Okay, there's your diagram. Forward activation energy means reactants to the top, reactants are at the beginning. So it's going to be between these two lines. I'm going to draw like 6 lines on here. Any one would be right. I'm going to draw the first one in the most obvious spot. That's the most obvious spot, reactant to the top. But you could put it here, 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 right? Or even, look, see where I've drawn all of those? I'm going to draw one more. You can even draw it here. It doesn't matter width. I drew the one like even off the grid. I wouldn't do that on a test. I would put it where I put the first one that I showed you. But it doesn't matter where the line is with respect to left to right progression. It's where the line starts and stops that matters. Forward activation energy has to get up to where the activated complex is, and it has to start where the reactants are, up and down. 18. All right. There's a lot of explanation here. I'm going to go right to the question. It says, state in terms of concentration evidence that indicates the system in the flask has reached equilibrium. The lines have become parallel to one another. They become level. Okay? That's the equilibrium point. I'm circling on my little picture here the areas that show equilibrium. Those are the areas that show equilibrium. Right? Number 19, explain in terms of collision theory. So we got to say something about collision, why the rate of the forward reaction decreases when there's less N2. If there's less N2, there'll be less collisions, less rate. Last page. This 20, 21, and 22, a little bit harder, a little bit more complicated just because of the way the drawing is. I only put a question on here like this once. Usually they're more like the previous one that we did with these concentration curves. All right, number 20. It says, explain in terms of collision theory why the concentration of H2 begins to decrease immediately after more H2 is added. All right, so I'm going to try and show this to you here. Okay, you see there's 3 sections, the white, I got to look this way, the white section, the slightly darker section, and then the somewhat in between colored section. That represents 3 different time periods in this reaction. The first time period is before anything has happened. With the addition of hydrogen, the system has come to equilibrium. So it's at equilibrium now. And then, I know you can see there's this little jump up right here. That's the time when more H2 is added. So now I've added more H2. Those H2s are going to start to react, so our equilibrium is shifting. At that point, after more H2 is added, it begins to react with the N2. You're going to notice H2 and N2, our reactants begin to decrease, and this is making NH3. The NH3 increases. Let me draw your attention back up to the initial reaction, right? N2 and H2, those are our reactants. We're making NH3. We add more H2. It reacts with the NH3, creating forward reaction. NH3 increases, and the H2 and N2, after the N2 is added, right? That's why it shoots up. They're adding more, boom, goes up. And then the H2 and the N2 begin to decrease, okay? So the answer to the question is, explain in terms of collision theory, we got to say collisions. There's more H2 to collide with the N2. And then when the H2 and N2 collide, we get forward reaction, making more NH3. All you have to say is there's more H2 to collide with the N2. Number 21, explain in terms of Le Chatelier's principle why the final concentration of NH3 is greater after the initial concentration. More H2 was added, shifting the equilibrium to the right, getting more forward reaction. You could say either. Usually a question that deals with Le Chatelier, you can simply say shift left or shift right, or no shift. Well, there were a couple of questions that we went over yesterday on another page that had no shift. Catalyst doesn't cause a shift. If the gases on either side are equal, there's no shift. But Le Chatelier is shifting, or you can say more forward reaction, which indicates a shift to the right. Number 22, when information on the graph indicates that the system is at equilibrium again, the lines become flat or parallel again, or horizontal, not vertical. Don't say straight, because straight could be straight up. Okay, so straight up is different than flat, horizontal. Okay, so horizontal or flat. Don't say vertical or straight. Number 22, what information on the graph indicates the system was initially at equilibrium? For some reason, I felt I read this question already. Oh, I think it was the same as 19 on the previous page. The lines were flat. Okay. And number 23, circle the 182.6. The 182.6 is on the left, indicating an endothermic. That means from start to finish, we have to go up in energy. So we're going to start low and go high, okay? Starting low and going high. Then we have to put a point for the activation energy, which is higher than both the products and reactants, and then connect it with a smooth line. Okay? And it looks like this. I'm going to put on sets of questions. I'm going to put on 15 entropy questions, 80 practice questions for the test, and I'm going to post the schedule that I'd like you to have them done. We're going to have them done and finished reviewed by Monday, and I'm going to put that schedule up, typed along with the links for the documents. All right, make sure you're able to print out 2 sets of documents, 80 questions and 15 questions, and I'm going to go over them slowly over the course of Thursday, Friday, and Monday. I'll take any other questions on Tuesday, and then you'll have to take the test either Tuesday afternoon or Wednesday. Have a good day. See everyone tomorrow.